In 2009, an American security researcher by the name of Moxie Marlin Spike have discovered a way to do a man-in-the-middle attack and completely inspect encrypted content by stripping the HTTPS protocol from requests. It was a very brilliant attack that was discovered back in 2009. And then you might know Moxie from his previous work. He was head of the security engineering, I believe, in Twitter, and he's the creator of Signal, the messenger app, and the end-to-end encryption concept. But the SSL stripping attack took the world by surprise, and the browser community started flailing to patch it. And it came up with multiple ways to patch it, but none of them were completely 100% effective. So in this episode of the Backend Engineering Show, I'd like to go through what was the SSL stripping attack, how was it executed, what are the methods of prevention that were invented, and how was it finally circumvented, and discussing things like HSTS, HTTP strict transport security, and other stuff as well in the process. How about we jump into it? Welcome to the Backend Engineering Show with your host Hussein Nasser. And SSL stripping is a genius attack. Before we talk about it, we need to kind of talk about the existing architecture of the internet when it comes to security on web applications back in the early 2000s. Back in the early 2000s, when you want to host your website, you literally just spin up an Apache server or any web server, throw your static content there, and voila, listen to port 80, and you have an HTTP server. So the content that you're serving from your web server was most of the time unencrypted. And which means if you are a client and you want to connect to this web server, you will only establish a TCP connection and literally follow it up with a git slash, and then get the content, and the content will be transferred in an HTTP form, and then you're going to get the content. So it's completely unencrypted. So as a result, 99% of the web was mostly unencrypted. That was like early 2000s, mid 2000s, even late 2000s. But then people discovered that this was silly, because now everyone who's listening in the middle, right? And I don't mean someone sitting in the ocean and monitoring the routers. No. By everyone, really, we mean the ISPs, we mean the Starbucks routers, administrators, right? People who connect to Wi-Fi can look at everything, right? Including your banking transactions and stuff like that. It was just silly, right? We should have never done that. But nevertheless, we did, right? So HTTPS was introduced, and you might say, what is HTTPS? It's nothing really but HTTP. The only difference that we did is we added an extra handshake after the TCP to encrypt the communication, right? And the rest is just pure HTTP, right? So it's called HTTPS, but it's just HTTP on secure channel. And it wasn't as simple as we thought it would be, because now all of a sudden we needed not just security, right? That means encryption between two parties, because guess what? Parties in the middle, such as ISPs, such as anyone intercepting in the middle, can still break this encryption, right? Because like, hey, I'm going to see that you're trying to encrypt a channel, right? And I'm going to intercept that, and I'm going to reply back. with my own version of the encryption. So you'd think that you're talking to the server, but you're not. I'm just going to I'm going to terminate the TLS, right? It used to be called SSL back then. But then, so it's absolutely useless to encrypt, right? Without knowing that you're actually connecting to the actual server that you asked it to do, right? So SSL and TLS was useless without some sort of an authentication. We need to know that I'm absolutely 100% sure connecting to the server, right? And no one terminated that and served me some other defaultment parameters and then other encryption keys, right? So we introduced the concept of certificates and certificate authorities and root certificates, and I talked about all that stuff, right? But effectively, this is a way that using public key cryptography, the server always generates a private and public key, and then puts their public key in a certificate, and then sign it with their, and then adds a signature that's okay, this is my private key. But that's not enough, because that's kind of a self-signed certificate. So we brought up some third party called certificate authorities, which have their own private and public key, and they're going to use their private key to sign that certificate, proving that this is google.com, this is nationalgeographic.com, this is bankofamerica.com. So we're relying on third party, and this is still the only solution. We didn't find another solution to that problem, right? And guys, always keep in mind that nothing that we're using is perfect. Nothing, right? Some engineers might show you that, oh, this is the way to learn something. Nothing's perfect. One of you listening now can come up with a flaw in whatever we're saying here, and then nobody have thought about it, right? Just like Moxie, right? There might be another Moxie lurking in the dark and finding a bug in our security model that will just take the world by surprise again. So yeah, we're using certificate. Now we have some sort of a full model that, okay, now it's a secure encrypted, and we know that we're actually talking to the server, because I'm going to receive a certificate and nobody else has this certificate except this guy, right? And you cannot fake the certificate, because you need to have a certificate authority that is trusted to sign your certificate, which nobody does except Kazakhstan, which they actually did. Right, Kazakhstan government for a long time tried to serve certificate that belonged to Google, claims to belong to Google, signed by their own certificate authority, that is the government of Kaz. I think it's called Kaznet, right? and serve it. So you would know that, oh, I'm actually talking to Google. You might say, Hussein, how would a browser and your machine trust that this is actually the certificate of Google? Well, all the laptops and mobile phones in Kazakhstan is probably provided by the government, so they will have installed a root certificate on all those machines. That's what's happened to China as well, I believe, where, oh, Kaznet is actually a trusted certificate root. So when you do this cyclical authentication, you go all the way to the all the way to the root, and your machine says, oh, I trust Kaznet. That's a good one, actually. That's why never install any certificates on your machine unless you know what you're doing, right? That's very dangerous stuff. Or don't buy some cheap laptop from, like, I don't know, China or somewhere else, right, that has a pre-canned operating system with all these certificates, shady certificates that has it, because someone can install a certificate authority or certificate root that can break this encryption. Anyway, we're going all over the place, but it's still on topic, I believe. We're gonna come to SSL stripping in a minute, but now we have partially encrypted the internet, and yeah, there is some sort of what do you call friction to encrypt things. It's not really as easy right now. Previously, just to spin up a web server, port 80, you're done. Now you have to encrypt. Right, to encrypt, you need a certificate authority to create a certificate. Like, how do I do that? I never done this before. You have to pay money for DigiCert and other companies to sign. You know, that's expensive. So Let's Encrypt came up with a good model where a 3-month certificate for free, and you get it for free. And using domain authentication, you're gonna get a certificate for free. So now nobody ever have an excuse not to encrypt anymore with the Let's Encrypt, right? And then Caddy's web server kind of started the march back in 2005, I believe, 2015. Sorry, 2015. They started the march by web encrypted first. Web, right? So your web server is always encrypted by default, secured by default. That's kind of broke all excuses. You don't have any excuse, right? They made it. What's his name? I forgot his name. The creator of Caddy. I'm sure it's gonna come to my mind. But he made it. So that's easy. It's just like a literally spin up and then give me your domain name. As long as you actually have a domain that points to your IP address, I'll figure out. I'll talk to Let's Encrypt or whatever certificate authority, and I'll generate one for you. So it's so simple, becomes so simple. So most of the web becomes encrypted now. Everything is now almost encrypted. These days, everything is encrypted. And now let's go to the browser. Let's discuss what the browser is doing with all these things, right? The browser is also evolving, right? What does it mean when I go to twitter.com, I hit enter, or bankofamerica.com and I hit enter, right? What does that mean, right? Is that an encrypted or not encrypted? And how does the browser know that the actual server supports SSL or support TLS? It doesn't, right? So the browsers for a long time, if you don't explicitly specify the protocol, that is this HTTPS / or HTTP // it's gonna make a guess. And the guess was, for the longest time, go unencrypted, go HTTP first, and let the server tell us if they want to redirect the traffic to HTTPS. And that's what the browsers most of the time did, and that's what the web servers did. Like, we prefer encrypted communication over unencrypted, right? But how do we tell the browsers to actually redirect, right? It is really simple, right? You add a redirect 304, 302, whatever that thing code is. It says, okay, when someone is establishing an unencrypted communication with me on HTTP / twitter.com or google.com or bankofamerica.com or mywebsite.com, then I don't serve them content. I reply instead with, hey, you're on the wrong place. Please go to this location, and the location is HTTPS // and that will convert the unencrypted channel to an encrypted channel. But remember, and then everything after that is completely encrypted, but there is a cost. There is a heartbeat where at the beginning of the communication between me and the website was unencrypted. So anybody in the middle can and will listen, read, and not just listen. That's what Moxie did here. Can do nasty stuff. That's when SSL stripping came into the picture. Let's take an actual example with Bank of America. Let's say when you type in Bank of America, users almost never type in HTTPS : / Bank of America, right? They don't know that. Most users, right? Most of us, let's be honest, like we just type Bank of America or whatever the site, even we search in Google and then we click the site on Google, right? But if you actually type in bankofamerica.com and you hit enter in this Omni box, What happened is you didn't specify the protocol, so the browser will make a guess, and the guess is has been always until literally last month or 2 months ago, HTTP. Hey, I'm gonna go to HTTP. And when you go to HTTP, that's a TCP followed by a GET request, which can be easily intercepted. So if I am a man-in-the-middle attacker, and you are, I don't know, let's say you're doing all this banking transactions on Starbucks Wi-Fi, and I managed to do an R poisoning on the Starbucks router, so that I pretended to be the gateway. That means any IP address that is outside the subnet of Starbucks will go through me instead of the router, right? So if that's the case, all the traffic goes through my laptop, which is the attacker's laptop, and then I will forward the traffic to the actual router. So I have full access to read, write, change to responses and requests, right? So now I see someone is trying to go to Bank of America, and I can't see it because it's fully unencrypted, right? So I see the GET request going to Bank of America, HTTP, plain text. So that's harmless, right? Most of the time. I stop the request and I make my own request to Bank of America. Again, HTTP. Bank of America will reply back to me, which is the attacker, saying, hey, you're in the wrong place. Go to this URL instead, HTTPS. Remember, the client, the legitimate victim, is waiting for the response. I didn't give him that response. I'm going to respond to Bank of America with a TLS connection. I'm going to actually establish a connection to you on the secure channel that you want, Bank of America, and I'm going to encrypt that channel, and I'm as an attacker, and I'm going to actually send the GET request and encrypt it. And Bank of America doesn't know that I'm an attacker or an actual victim, doesn't know anything, right? So now I get back all the Bank of America results, right? Which are encrypted. What I do, an HTML page, which has a bunch of HTTPS links, which has a bunch of HTTPS redirection. I have all that stuff. I strip all the HTTPS and convert it into HTTP, and then paste the response that we blocked originally from the victim to the victim. Say, hey, that's the page you asked for, right? As long as we know you communicated to us through HTTP, and here's the Bank of America in plain unencrypted HTTP. Yikesy. So now we have a Bank of America page that says username password. Give me the username and password. Most users will just, oh, this is actually Bank of America, and they're not lying. So I'm going to type in my username. I'm going to type in my password in an unencrypted channel. I'm going to hit send. This is unencrypted, so the password will not be encrypted. So the username nothing is encrypted. You send that to me, right? Because I'm in the middle. I take that username, the precious username and password, I save it somehow for future use. And I'm not gonna fail you, user. I'm actually turning around and I'm making the same GET request to Bank of America, same post, because it's a login, right? I'm gonna make it, don't worry. I'm gonna make it on your behalf. So I'll take your username, take your password, and send it to Bank of America in a secure channel. And then I'm gonna get a beautiful login page with your bank balances and all the things, because as far as they know, Bank of America will also send me the cookie. It says, hey, by the way, don't bother logging in the future. just hey, here's a cookie. And I'm gonna send back the cookie to the user. And all of a sudden, anything that you do is through this unsecure channel. And you have no clue that this is happening. Everybody's listening to that. And I made a video about this with Google even. Like even Google for the longest time. Right? I'm going to reference the video. It's like if you type google.com, not www.google, if you type google.com and hit enter, that always, most of the time, was unencrypted, which is dangerous to me. Like nobody types www.google.com. Everybody most probably just type Google or just search. Probably a search in the address bar is more secure than actually typing google.com, hitting enter, and then searching, right? Because the first request to go to google.com is an unencrypted HTTP, so anyone can do exactly what we explained here, right? And then there's a redirection. Okay, go to HTTPS, right? That is why people tell you all the time, make sure that you're actually in a browser with a padlock, that you're actually encrypted, right? If you are in an encrypted channel, then you can be safe, not all the time, for reasons we kind of talked about, right? Like the certificate has been forged and your machine has unexpectedly trusted that forged certificate, but that's another topic for another day. So that's SSL stripping. SSL stripping. We got SSL because that was way before, I believe, TLS was invented, even 2009, right? That's the year Michael Jackson died, I believe. I remember it very clearly. You know, guys, whenever there is like a big event, you always remember where you are, right? For some reason, like the emotional attachment to like the death or the 9/11 or to anything, you always remember exactly where you were, right? There's like a snapshot image in my head. I remember exactly where I was. I don't remember before it and after, but that moment, I found it. I remember finding it in my BlackBerry. I clearly found the news in my BlackBerry back in 2009. Right. In 2001, when the attack happened, I remember I was in my sister's room and I was watching the small television, and it was there. I remember exactly that. There is a snapshot. I don't know if that was just me, but anyway, 2009. That's SSL stripping. Now, browsers, vendors, and you know, that was like the year where Chrome started becoming like popular, right? Firefox, everybody starts scrambling. It was like, what do we do? Naturally, right? You might say, Hussein, let's always communicate in HTTPS first, right? Back in 2009, let's not, in the case of if the user didn't specify the protocol HTTP or HTTPS, let's always communicate in HTTPS. Back in 2009, that was not an acceptable solution because many websites were not encrypted, because we talked about that and certificates, and it was really hard to get. It's like nobody get, if I'm like want to build a forum or whatever was popular these days, like I don't want secure and pay for whatever that thing's $2,000 at that time for a year. Let it unencrypted, I don't care. So if the browsers did that, if the browsers always assume HTTPS, then the failure rate will become much higher as a result. And as a result, users, normal users, not tech savvy per se, will freak out, right? It says, whoa, I went to this government website and I want to pay my taxes, whatever, and or the DMV, and now I'm getting an error, or the site is so slow to load, whatever, right? So there was like many solutions that you can have done. You can okay, let's establish an HTTPS first, and then if it didn't work, let's go back to HTTP, right? I don't know why they didn't do that, right? Because like, let's do this asynchronously. Let's establish two, and if HTTPS worked, go to HTTP, right? But that will be kind of almost a denial of service for the site, because that's two connections instead of one. Plus the performance reasons, like, okay, what's if port 443 is not open? You want me to open that and then close? There's a lot of work, right? So browsers came in with a partial solution. So you know what? Let the backend tell us if it's secure or not. So we're going to execute an unencrypted site, right? An unencrypted call, HTTP, to Bank of America. And Bank of America is going to tell us that, okay, hey, I'm actually secure. Please go to this site. And by the way, for the next year, always communicate HTTPS, because I guarantee I have a certificate. I bought this thing. So it's going to be fantastic. Always HTTPS. Don't worry about it. So the browsers will look for that header. I believe it's called HTTP Strict Transport Security, or HSTS for short. And the client will say, okay, I will update my list. You Bank of America, you're good. I will always in the future, if a user didn't specify a protocol and says bankofamerica.com, hit enter, or they clicked on a link, or they did a curl, or they did they did a fetch. Fetch didn't exist back 2009. And they did I don't know, XML HTTP request. Right? I'm always gonna go through HTTPS. And then Google said, oh, us too, Yahoo, everyone just like jumped in. So HSTS came up with another idea called the preloaded list. It's like, okay, let's make up with a list. Let's come up with a list, right, with everything that is encrypted, and you can see how big this list is. Right? So now you query this link, right, this domain, right, and look if this site is encrypted or not. So now the browser's obviously size increases because there is a database that I have to maintain that I didn't have to before. And then as we continue with the years, this list grew larger and larger and larger, right? Because like everything almost getting encrypted by default, right? So there was like no reason anymore to maintain this list. But what was the limitation of HSTS? The limitation is still the first request still is unencrypted, right? So the very first is always unencrypted. Yeah, so HSTS wasn't perfect. The first unencrypted call, right, though unlikely that an attacker might get it, right, is unencrypted, right? And the subsequent ones will always be encrypted, but there's still a chance that someone can get it. But there's still another path. If you are on a page that is unencrypted, right, using pure HTTP, and the links inside this unencrypted page is actually encrypted, it's pointing to HTTPS / Bank of America, right? It's like, oh, click here to visit the Bank of America, for example, right? And it's encrypted HTTPS, says clear HTTPS. That is still not safe because the page was loaded using an unencrypted HTTP. So if an attacker saw all this content of the page, they will see HTTPS Bank of America and they can easily strip that and replace it with HTTP : / Bank of America. And when you actually do that, the browser will not say, oh, Bank of America told me to go to HTTPS. No, the user technically asked for the HTTP, so we're going to respect that. That's another problem with HSTS. Remember, HSTS will only kick in when you don't specify the protocol, right? But if we actually do, and you say HTTP, then, hey, the user asked for HTTP. I'm not going to say no, right? So it will obey that. We have these problems with HSTS, and then savvy security people and tech people always install this thing that's called the HTTPS everywhere, which always forces HTTPS connection before HTTP, right? Thus, you're always knowing that you're establishing a secure connection first. And that protected people. And I've been using this for a while too. Until Chrome, I believe, started this thing. It says, okay, let's end this nonsense. Everybody's almost encrypted. We're always going to go through HTTPS first. regardless. There's no mumbo jumbo. Yeah, the chances that connection will fail, and we want to fail. You won in 2021. You want a connection to fail if the server is unencrypted. It started discouraging people from visiting unencrypted websites, showing this huge not secure banner on the, or in cases like there's like a bad luck red and X, right? There is an X button, then open, stuff like that. So it's scary, always like an errors wherever you go. So users now are almost educated that, oh, I'm not supposed to visit this site because it's unencrypted. Mind you that you might get this error when your certificate is expired, and that causes havoc, or your date or has been revoked or stuff like that, right? So this does causes some mania between users when they see this error, like, oh, the site does not working. Well, it is working, but the certificate has been expired, for example. All right, guys. So to end and summarize this backend engineering show episode, SSL stripping attack was discovered by Moxie back in 2009. It was as a result of this redirection to a secure website, right, to encrypt the communication. But because that redirection is unencrypted, someone can intercept and change and strip HTTPS altogether to HTTP, strip the encryption, right, and perform a full complete encryption on the backend. So browsers' knee-jerk reaction was to come up with HSTS, HTTP Strict Transport Security, which means, okay, let the backend tell us that if the backend is actually secure or not, and in the future will always be secure. We're gonna communicate in a secure manner if a protocol is not provided, right? So as a result, the first request always go through an unencrypted channel, but the server says, hey, I'm actually secure. Always connect to HTTPS //backofamerica.com instead of HTTP. Please let us be secure, and then we will close the connection, and then in the future always communicate in HTTPS, right? And then every future request will always be secure, right? So that's good. We had flaws with HSTS, as we talked about. The first request is still unencrypted, plus the preloaded list is huge, so searching become challenging because you need to database, right? And something I didn't need to manage before. Plus I need to searching is expensive. You have to index, and that index also creates a size problem with this billions of websites that I have. So and the worst of them is like still the HTTPS HSTS is useless if it's being served in an HTTP website, in an unencrypted website where the links are pointing to HTTPS, right? So and that's why most of the time now the browsers prevent this mixed mode. You can't be in HTTP site pointing to HTTPS and vice versa. You can't be in HTTPS website and pointing to unencrypted. They touch all of this stuff. Chrome tries as much as possible to discourage people from visiting unencrypted websites, right? Because of these attacks. And then finally Chrome says, put the nail in the coffin, and other browsers follows as well, saying, hey, no more this shenanigans. We're always going to communicate in HTTPS all the time, right? Because we're in 2021 and every web server now has to be encrypted by default. And Let's Encrypt and other sites, other certificate authority made this so easy to generate certificates, right? Web servers like Caddy took the charge and forced that, communicate with it, so can make things so easy to start, right? And now sites like Netlify, things like that, and what is the other things? Squarespace and stuff like that. All of these websites now, if you're not a developer, you just you can create your own blog, and they will take care of the encryption, certificate generation, all that stuff for you. So everything is almost now encrypted, so there's no reason really to not encrypt your website. Mind you that, yeah, while there is no everybody is now encrypted, doesn't mean that it is always good, because now the attacker's websites are also encrypted, right? And so if you're visiting Bank of America with AAA, right, .com, that is not, and if you see that padlock, and if the page looks identical to Bank of America, that doesn't mean anything, right? Because anyone could have sign, Let's Encrypt could have easily sign, because they don't verify this stuff. You know how many certificates they sign every day? I have no idea, but it's probably a lot. So you can technically create a site that looks like Bank of America with a C or something like that. It's like a single typo, and then copy and paste the HTML of Bank of America, and you send it over, and people will think they are in Bank of America, and they are legitimate, they have security, everything. The browser will tell you that, hey, this actually looks good, unless until it's shut down. So it is scary worse. So phishing attack will only go good worse from here. So all right, guys, that was just a video about the SSL stripping. I found it interesting to look through the history of the evolution of how security are mitigated, and I believe this battle, right, while terminated for SSL stripping, I don't think it exists anymore. Other problems will definitely come in to replace it. Hey guys, Hussein from editing, and SSL stripping is not going away anytime soon. That is a slight correction to that statement, because while when you don't specify the protocol HTTP versus HTTPS, right, the browser will always go to HTTPS. Now, still, if someone social engineered someone to forcefully visit HTTP : / Bank of America, then you can definitely still perform an SSL strip attack, right? That is why the backend should disable HTTP if they don't ever want anyone to. This is the extreme security. Just disable HTTP altogether, right? That is the best thing, right? And even if you did disable that, I mean, I still believe the attacker can trick you, right? Because you send that GET request, right? They will terminate it. They will find out that port 80 is disabled on the back end, but they will establish the connection to 443, and they will trick you, right, to continue using an unencrypted website. So I don't think SSL stripping is going away. So that's just a slight correction. As I was just listening to the video again and then editing it, I add all these late statements, and yeah, that's just another addition. Let's go back to the video. Thank you so much for listening and watching, and I'm gonna see you in the next one. You guys all stay awesome all this. Goodbye.